Hi everyone. In today's video, we are going to talk about DVC or data version control. Right now, I am in DVC's official documentation page and you can see it's data version control. What is that? It manages and version images, audio, video and text files in storage and organize your ML modeling process into a reproducible flow, right? What it does, it's a perfect fit for processing and versioning of millions of files in cloud storages. Explore, enrich datasets, build semantic layer for your unstructured data. It version and save data, connect to code, track experiment, register models, all based on GitHub's principles. So these all things we can do using DVC. And if I click on this doc button, I will come to the page of DVC's documentation, and if I click on install and if I click on Windows and if I click on install with pip, how you can install DVC in your laptop? Just running this command pip install DVC, and you should have a function Python version of 3.8 plus. That's what is the requirement here. Okay, and that's what you have to do. Okay, as of now, and there are many things that these guys have mentioned about it. Okay, and if I come into this get started one, the data pipeline. What is this data pipeline? Use pipelines to describe how models and other artifacts are built and provide an efficient way to reproduce them. That's what we are going to do today. We are going to create a complete ML pipeline using DVC. Okay. And in next few videos, we'll explore these metrics, parameters, plots, experiment, tracking and everything. See, DVC, see, if you want to do experiment tracking, metrics, parameters, and plots, right? ML flow is better than DVC, what I feel. Even in industry, also, ML flow is used mostly. Okay, but still, I will show you how to do that. But when we do end to end projects, there we use DVC only for the pipelining part, and we use ML flow for other tracking, experiment tracking, metrics tracking, and everything. Okay. So if I go back to the code that I have prepared for you guys, first of all, I need to explain you a few things. First, before doing anything, let me clear this one first. Before doing anything, let's understand what we have here. So I have a CSV called this one, art.csv. This is the data in our scenario. And using this data, we are going to build a machine learning solution. Okay. So here we have to predict this. This target is the target column, and you have to predict you have heart disease or not. 1 or 0. It's a binary problem. Okay. Now, before starting anything, first you need to create an environment. For that, you come in this readme.md file, and I have kept the commands here. You just copy this command and run in the terminal. And you can see this environment is created. Now I need to activate the environment. To activate the environment, you need to run this command. Okay, and run this and press enter. And you can see my environment is activated. Now I need to create a requirement.txt file. So in that file, I have mentioned what all this your libraries that we are going to use. So all these names are mentioned here. Okay, and how I have to install them? I have to run this command pip install -r requirements.txt. Okay, I will copy this one and I run this command. Let it install all the dependencies, then we will talk. Okay, let this thing get installed. Till then, let me explain you a few things. If I come back to this experiment.ipnb file, here you can see I have kept some codes. That code actually we are going to write in different py files. Okay. So first let me explain you what I have done here. I have import few of the libraries. Then I have read the data. I have read the data from this data folder, hard CSV. This one I read. And this is the data set. Okay. These are the folders and all, not folders. These are the columns and the row values and everything we have here. This is how I am calculating how many columns I have. And now target column is the target column in our scenario. So I have split it into X and Y. Okay. And after that, I have done something called train test split. As you know, guys, you do splitting a lot many times you have done. So same way, I am doing train test split. Now I am splitting the data. Then I am using K nearest neighbor here. That is a machine learning model that we are going to build here. Okay. And now I have done it, I think 21 times, and I wanted to see how the performance is based on different K values. Okay, and according to that, I have decided some K value in our case. See guys, this is a very basic ML workflow. Okay, and the model is also very basic, data is also very basic, because I wanted to explain you this DVC pipeline in the easiest way, so that you will understand. Because when you do end-to-end projects, there you will do the toughest part. Okay, but I want to first explain you properly this DVC pipeline, how to build that, and that is why I took this very easy use case. And now you can see I have chosen this n neighbors as 19. You can choose any one of them. Okay, I have just hypothetically I have chosen this 19. I have fit on the training data. Then I have called this precision recall, F1 score. These all metrics we use in classification. And then I have called predict. And then I print all the values. Okay, but as I told you in the theoretical section, right, that this is not a good way of coding. If your code is breaking anywhere, right, you have to change the whole code, or you must rewrite the whole code, and that is why you follow some modular fashion. So what all this modular fashion? See, for each and every process, I have created a specific py files. First is data ingestion.py. Here I have imported few of the libraries. Okay, and then I have created a function called load dataset. This function will read the CSV, then create a y and x for me, and it will return the x and y. Okay, simple it is. Next is split dataset. So what I am doing here, I am splitting, I am taking the x and y. This x and y I am taking here as an input. Then I am splitting them, and I am storing all of this splitted one, xtrain, xtest, ytrain, ytest, in splitted data folder. I am creating a folder here, splitted data, and I'm keeping all of them here. And this is the code that is running all this thing. Okay, that's simple it is. Now after data ingestion, we have model trainer.py. Here I am training the model. And for that also I have created another function, train model. It will take training data, xtrain, ytrain, it will take as an input, and model save path, where we are saving the model. Okay, so this is the models folder, and inside the models folder we are having a model.pickle file that we are saving. Okay, next, this is all called knn classifier, one variable I have created, and now I am doing k neighbors classifier. I am taking this k neighbors classifier that last time I did, right, in this one. Here I have done that, right. Likewise, I am doing here k neighbors classifier, and I am taking k value as 19, and then I am fitting the data. Okay, after fitting it, I have not done any checkup. Okay, here no accuracy metrics, nothing, no metrics I have used here, because I wanted to explain you the DVC pipeline instead of how to build model properly, right? And that is why I have directly saved that model using job.lib in this path. Okay, if you come in the models folder, you can see this pickle file. Okay, because before recording this whole video, right, I have executed the code to make sure that things are running properly. Again, I'll execute in front of you also, so no need to worry about that. So I have written something called true. Why I have done that? Because if this code is failing, I'll get some other values, but true means my code is working fine, right? Now I'm reading the training data. Okay, I'm training the model. That's simple I'm doing. After that, the last stage is eval.py. Here I am doing again simple thing. I am again evaluating the model. I am taking the testing data. Okay. After loading this testing data, what I am doing? I am predicting the values. Okay. Then I am returning a dictionary. And in the dictionary, I have precision, I have recall, I have F1 score, I have ROC score. So these all things I have returned here. And now in this one, I have read all this testing data and I have passed into evaluate model. That's the whole workflow. These three py files that I have created here. Now we need to create the pipeline. For that, what you have to do, you have to come here and you have to initialize your GitHub. So for that, you need to run the command called git init. Okay. So once you run the command called git init, your GitHub will be initialized here. First step. So next you have to do DVC init. You need to initialize DVC also. And my DVC is also initialized. You can see from here. See, something like this will come if your DVC initialized properly. Okay. You can see initialize DVC repository. Okay. Now I have to create a dbc.yml. Okay. And in this YML only we'll define the whole pipeline. How it works? For that you need to create a variable called stages. And now in the stages I have three stages: data ingestion, model building, model evaluation. See, this data ingestion you can keep any name. Anything is fine. But for the intuition purpose, I have kept as a data ingestion, model building and model evaluation. Now for data ingestion, first of all, you need to write cmd is the command. What command you need to run in this stage? I want to run this data ingestion.py, right? And that is why what I have done, I kept like Python data ingestion.py. Okay. And what all dependencies I have? This file itself are dependency for me, right? As well as the data folder is also a dependency for me. Why? Because inside this data folder only I have the CSV file that I am reading from it, right? So that is why it is a dependency. And what is the output? Output is inside the splitted data folder only my CSVs are getting stored after the splitting. And that is why this is the output in my scenario. Okay. Now next, the model building stage. So once data ingestion is done, I have my model building stage, and inside this model trainer.py file only, I have this all code for training the model. Again, dependency this py file itself. And what is the output? We are saving the model inside this models folder, right? So that is why you can see I have kept like models model.pickle file. Okay. This is the output file that we have here. Next is your model evaluation. And for model evaluation, I have to run this eval.py file, Python eval.py. And what are dependencies I have, guys? See, this model is also a dependency because this model we are reading, then only we are able to do the evaluation task, right? And that is why I have taken this model.pickle file. And after that, this eval.py file. This file itself is also a dependency. Okay. So this is the whole answer workflow that I wanted to define. So now you don't have to do anything. Just come into this terminal and type DVC repro. DVC repro means DVC reproduce. Now you have to reproduce whole pipeline. You have to rerun this data ingestion py file, model trainer py file, evaluation py file. If there are any changes in your data, if there are any changes in your data, and if you run this DVC repro, it will rerun the whole pipeline. So you don't have to do anything. You just need to run DVC repro. If you see, this is running now. See, this stage, data ingestion stage is running right now. So let it run. Then you will see the next stage will also run one by one. See, this ran successfully. Then model building stage is running right now. And see, now evaluation stage is running right now, and we got the output like this is a dictionary we got as an output. And all these things are stored. See, all the metadata of this whole workflow stored inside dvc.log file. And this log file will work as a versioning in your code. So you can see the schema 2.0, and for this kind of metadata you are getting. Okay. So this is how you can create a beautiful workflow, a complete ML workflow using DVC. And see guys, our code ran successfully, right? So, and right now I have not done any changes in the dataset, correct? So if I do DVC, let me clear first. If I run DVC repro, you will see something else. Let it run first. You can see it's saying like stage renderization didn't change skipping, stage model building didn't change skipping, same for model evaluation. What does it mean? That there is no changes in any one of the stages, and that is why your pipeline data and the pipelines are up to date. So that's why it is not rerunning the pipeline again. So this is really cool, right? So if you don't have any changes in any one of the stages, your pipeline won't run again. But if I do a small change in the data set, okay, let's do a change, like go to hard.csv and let's make this one as 0. Okay, I hope there are other zeros should also be there. Yeah, I have done a very small changes, right? And now if I run DVC repro, you will see it will track the changes that I have done in the data set. That is why it will rerun the whole pipeline. DVC repro. I am running DVC repro again. Now you will see the magic. So see, now this is running. This stage is running. Why this stage is running? Because I have made changes in the data set, and that is why as this stage, this data set is in the dependency inside the data ingestion stage. That is why it reran the whole data ingestion.py. But it did not run this model building. I did not run this model evaluation. Why? Because there are no changes that I have made for these stages, and that is why it has not run the code again. So this is the dynamicity we have when you use DVC. Your pipeline will work efficiently, and that is what I wanted to show you in this video. And in the next video onwards, we will see a few more things about DVC. But yeah, so you can keep this data code and everything. I will give the code as a zip file with this resource so that you can use and utilize in your scenario also. So I hope you guys have understood what all things I have mentioned you. Okay, so stay tuned for further videos.